The black hole was discovered after astronomers measured the motions and brightnesses of stars at the center of Omega Centauri. They found that these stars were moving much faster than expected given their total number and brightness. Such behavior clearly indicates the existence of something extraordinarily massive at the center of the cluster. The intense gravitational field of a black hole with a mass of 40,000 solar masses provides just the kick necessary to explain the measurements.
This is Dr. Eva Nojola of the Max Planck Institute for Extraterrestrial Physics in Germany. So Eva, you were the lead author on this study. How did you find this black hole?
The way we found this black hole was by looking at the Hubble image and measuring how many stars are there at the very center of this cluster. And then we take the GMO spectrograph and measure velocities, the velocities of these stars. What we find is that the velocities are much higher than what we would expect just from the stars. And that implies that there's an extra amount of mass there, it means that we found a black hole.
And what's so special about this black hole?
The very special thing about this black hole is that it has 40,000 solar masses in size. So that means it's a lot bigger than the stellar mass black holes that we find in our galaxy, but it's much smaller than the supermassive black holes that we find at the center of galaxies. So it means that nature makes black holes in a continuous mass range, not just in small and big sizes.
So what's the big deal? Why is it so important?
Well, first of all, this is only the second black hole that we find in a globular cluster, so that is a very nice, reassuring thing. But also, we know that there are seeds required to grow the supermassive black holes from scratch. And if we find many of these, then that would be a very nice source for these seeds to grow the supermassive black holes.
One implication of this discovery is that it is very likely that Omega Centauri is not a globular cluster at all, but rather some kind of dwarf galaxy that has been stripped of its outer stars and dark matter, as some scientists have suspected, for a few years. More than 2,000 years after Omega Centauri was wrongly classified as a star, its true nature is finally coming to light. But I wonder, does Omega Centauri have more surprises in store for us? This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
The NASA ESA Hubble Space Telescope has made the first detection ever of an organic molecule in a planet orbiting another star. This breakthrough is an important step in eventually identifying signs of life on a planet outside the solar system.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Traveling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the Hubblecast. In episode 12, we reported on the discovery of hazes and a red sunset on the extrasolar planet HD 189733b. Now, an entirely new set of remarkable Hubble observations of the same planet have shown that its atmosphere also contains lots of methane. Now, methane is one of the main constituents of natural gas, and this is the first time that an organic molecule has been found on a planet outside of our own solar system.
HD 189733b is located 63 light-years away in the constellation of Vulpecula, the Little Fox. This planet is so massive and so hot, it's considered to be an unlikely host for life. It is a hot Jupiter-type extrasolar planet and is so close to its parent star that it only takes just over 2 days to complete an orbit. The discovery comes after extensive observations made in May 2007 with Hubble's near-infrared camera and multi-object spectrometer. It also confirms the existence of water molecules in the planet's atmosphere, a discovery made originally by NASA's Spitzer Space Telescope in 2007.
Under the right circumstances, methane can play a key role in prebiotic chemistry. that is, in the chemical reactions that are necessary to form life as we know it. On Earth, methane, which consists of hydrogen and carbon, can be produced by lots of different things. From man-made sources such as waste landfills or as a byproduct of energy generation, to natural sources such as termites, the oceans, wetland environments, as well as livestock. But the temperature in the atmosphere of this gaseous planet is a scorching 900 degrees Celsius, and so it's absolutely impossible that life as we know it can exist here. So, in other words, it's pretty unlikely that there are cows on this planet. Instead, the methane is probably produced by some complex chemical process in the atmosphere that we don't yet fully understand.
The new measurements are an important step towards our ultimate goal of determining the conditions, such as temperature, pressure, winds, clouds, and the chemistry on planets where life could exist.
It's the lucky alignment between Earth, the extrasolar planet, and its parent star that makes this work possible. When the planet moves in front of its star as seen from Earth, then some small fraction of the light from the star has to pass through the atmosphere of the planet before being captured by Hubble. Now, in this way, the chemicals in the atmosphere of the planet can stamp their unique fingerprints onto the light, and astronomers can then see these fingerprints in the spectrum of the star.
By studying the thousands upon thousands of fingerprints in the stellar spectrum left by different chemicals in the planet's atmosphere, Hubble astronomers can work out its composition. The discovery of methane was a surprise to many. Astronomers are also intrigued by the amount of methane detected in the planet's atmosphere, much larger than any theoretical predictions.
The ultimate goal of studies like these is to identify prebiotic molecules in the atmospheres of planets in the habitable zone around other stars. That is, in the zone where the temperature is just right so that water can be liquid and doesn't freeze or evaporate away. Who knows what else we will find? This is Dr. J, signing off for the Hubblecast. Once again, nature surprised us beyond our wildest imagination.
The NASA ESA Hubble Space Telescope has captured a new image of the galaxy NGC 1132, which is most likely to be a cosmic fossil, the aftermath of an enormous multi-galactic pileup, where the carnage of collision after collision has built up a brilliant but fuzzy giant elliptical galaxy, far outshining typical galaxies.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Traveling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Welcome to the Hubblecast. In this episode, we'll take a close look at the latest image from the Hubble Space Telescope. It shows the giant elliptical galaxy NGC 1132. Now you may ask, what's so special about this fuzzy, seemingly bland object? Well, the interesting thing about it is not so much what it looks like today, but rather what happened in its past. So let's try to trace its history by taking a very close look at its present-day features.
NGC 1132 is located about 320 million light-years away from Earth in the constellation of Eridanus, the river. At first glance, NGC 1132 looks like any other ordinary elliptical galaxy. It is smooth, featureless, and contains hundreds of millions of stars whose yellowish color is a telltale sign of their great age. But closer up, we see that NGC 1132 is rather special. It's humongous. Many times larger than the average elliptical galaxy, it belongs to a category of galaxies called giant ellipticals. Seen in visible light, NGC 1132 appears as a single, almost isolated, giant galaxy. But this is only the tip of the iceberg. Scientists have found that NGC 1132